Hello, this is another video on this panel that I'm been playing around with. As you know, I've ordered these printed circuit boards, from JLC PCB, and you get 10 of them in a minimum order is usually 10. So here's a variation of what I've been playing around with. So the boards, well, you see this one I actually drilled holes through it, as you could see in that panel, and originally. Let me see. The panel was designed to use these boards. See, these are from Mollhem, MOLLEHEM.SE, Swedish company. So I have two of these boards. They have 16 inputs, and then they use a serial type RGB interface for the LEDs. So let me put that back. So in this design here, I have the switches. These are switches with LEDs, as you can see. So I'm only using the green, the lights to turn on green. So since the board could actually, each board, there's two boards, each board can operate 64 LEDs. So there's no way that I'm using them up. So what I'm actually doing is from one of the second board that I'm not using the LEDs, I actually just wired, see this little wire here, 3 wires is going into this board, and this is that string of lights that I was telling you can see in a previous video. They're like the Christmas tree type of lights. See, these are RGB lights, so it's just in and out. You see, they just daisy chain between each other, and they go all around the board. Use a little bit of hot glue, shove them in like that, drill those holes, and push the LEDs through. So each LED is considered like 3 lights, because it's R, G, and B. So red, green, and blue. The way I programmed it is it's to match this display. But since there's no switches, obviously on this display I can just turn their red lights, green LEDs. So I just either can just turn them on or off. But in this particular case, I can turn each individual light red, green, or blue, or a combination of red and green, which is yellow. So in this case, what you see down here is a representation of here. Like in this case, as you see, I've selected block D. Here a block Y, a block R, and then this block, and this one, and this one. So if you look to the panel there, you'll see this is represented as a green because the root is selected. This root selected, this one, and just I ran out of LEDs. I can, the string wasn't long enough, but if the string was long enough, I would just shove them in there and it would be pretty simple. The other thing is that with the red, see, I can either turn like I said, light red RGB. In this particular case, I'm using also the red. So when the root is not selected or not occupied, the light, see, it's these, like in this particular case, few of these lights are out. They're off. If the block is occupied, the light is red. If the block is selected, the root is selected, it's green. If the root is selected and it's occupied, the light will actually go to yellow. But it's just a little bit difficult to adjust. I would have to adjust the intensity of the yellow, because I'll show you what it looks like in a second. You see, here's the yard that it's representing here. So as you can see, let me see here. This is the root J. This is actually A. So A, F, J, and L. So here's A, B, C, D, E, F. Yeah, it's the same representation of there. So let me try and turn this panel so you can see everything. Put this there. So that panel there is telling me that there's a train on track B, which is this one here. So if I see, I tilt them off the track, what you're gonna see on the panel there is see the light on the bottom. It's see, the B goes out. Track C goes out. D is where the train is, the route is selected, but there's no train there. This other one, so the next block, see, it goes out. So all these blocks are occupied, and the ones that are not, I see, like if they were not occupied, the light just goes out. So I'll give an example. I'll select the route where the train is occupied. So let's say the route B is occupied, and I'll, from this panel, I'll select B. And if you look there, it might be hard to tell, but that light is actually yellow. So it went from, because the route is selected, and there's a train in that block. So if I take the train out, I'll just lean it over. See, the light goes to green. So which means the route is selected and unoccupied. If the train is occupied, the route is selected and occupied, it goes to yellow. So that's how that panel. See, so what's neat is without there's no extra hardware that I had to add. I just ran this little wire, since I'm not using those inputs on that panel, because each board, like I said, does 64 LEDs. But technically, when you use a RGB LED, that's like 3 LEDs. That's considered 3 LEDs. So you have to multiply this by 3. So I'm not using that. I'm only using 30 LEDs here. And then I'm using the rest from the other panel. I have an option for 64. I'm using them there. So, I take advantage of these boards. They're just, drill those holes, pass those LEDs. So, I can put them on different areas on the layout. Obviously, I can't, press any buttons over here because it's just for display. But it's a neat option of how I can continue to expand without using any hardware. But I get the different visual presentation. The other thing I was working on was this panel. See, I had one of my panels. That's the older version that I was using the Team Digital hardware. So that one has that one I installed it on the, as you can see in the fascia there where the control panel is. I'll just get a little closer. So we'll see. See, here's a track here. I'll just put a wet finger on the track, and you'll see the block gets occupied. I'll do one on this side. Let me see. Yeah, there you go. Another track. It's occupied, not occupied. See, so they go up. So, and the way I have that, I can show you. Open this panel. Make sure nothing gets stretched too much. Okay, so the way I have this is, like I said, originally it's for the Team Digital hardware, so the spacers are all set in place for these type of boards. Whereas the other board you saw, that one is made for the Molahem.se boards. So here, this is a CSC E board. This is what they call a SIC24 E board. And this is a homemade 30, I think it's 30 or 32 inputs. Yeah, 8 times 4, 32. So I could have used one of these boards, but anyway, making one of these is only like, it cost me like maybe $10, $8 or $10 to make. Whereas these ones go for like around $60. Mind you, they have all the smarts. Whereas this one, it's just the inputs, when I press the switches, it comes to the board, and the switch goes high or low, depending on how you set the board. But then it has to know, well, what do I do with that? So there was actually enough memory space on this board and this board, so I'm able to say, okay, if the input on that board, let's say whatever it is, however you programmed it, let's say input 23, or let's say you start at 20 and you count up. So let's say input 20 went high, so you tell it, okay, if input 20 goes high, then make the light in the front panel as occupied, and so forth, and then you just go through the whole thing. So like I said, that board is cheaper to make, but it doesn't have the smarts. So either you do the smarts on the other board, you add the logic, or you would have to use a program like JMRI to do the logic. So that's where that panel is installed. Okay, thanks for listening. Bye bye.